Hi everyone, welcome to another session. My name is Nilesh. You are watching world's number one crash course to be a cloud expert in hours. Today we will talk about Azure Blobs. Let's look at the concepts. So Azure Blob Storage is just one of the cloud offering from Microsoft Azure, where you can store massive amount of unstructured data. It can be text or binary data. Now, where all can we use blob storage? Yes, agreed. Microsoft is offering a bigger and larger storage, right? But where can I use Azure Blob? So when you have a scenario, something like serving images or documents directly to a browser, that is one. Storing files for distributed access, streaming videos or audios, writing to log files, storing data for analysis. There are so many things, right? Even backup and restore scenarios, you can store your data, different database or a VSD into that and restore it back. So there are so many scenarios available to use Azure Blob Storage. Now look at the high level overview. So you need to have an account. So here in this picture it is showing Sally. Sally is nothing but a storage account where you can have to create a blob. You need to have containers. You can relate it as a folder structure in your computer. So it is just a grouping of your blobs, right? So pictures and movies are containers where pictures contains image 1.jpg, image 2.jpg, and movies contains movies 1.avi, right? But I can store movie 1.avi into pictures also, but it is just a grouping, right? You need to understand it is just a logical grouping. You can put any blob into any container. There is no restriction. Now, what are the different types of blobs available? So Microsoft optimized your scenarios to store your data, right? So there are three different kind of blobs available. One is block blobs, second is append blobs, third is page blobs. So block blobs are mainly used for to store text and binary data. About 4.7 TB is what Microsoft recommends. Now, there is something called append blobs. What is the main difference between block blobs and append blobs? So, not much difference, but only thing is it is similar to block blobs, but it are grouped together or created together nearby. So it appends one by one blocks to the previous one, right? So it is more suited for something like you need to have logs, continuous logs, so your data is appended always nearby blocks. That is the main advantage. Now page blobs mainly used for to store if you have VHD files, that means the backup of VMs, right? So and it is in size of till 8 TB. So that is what the main use of page blobs. I have used it in my applications, mainly block blobs. So based on your scenario, you please choose. Okay. Now again, Microsoft categorized the blobs into storage tiers. So what is storage tier in Azure Blob Storage? So this is mainly based on the cost optimization. Previous slide shows about the performance optimization. Okay, so this is cost optimization. So when you use as hot storage, what happens is your applications data is used frequently, then you should use hot storage. Okay, but think of a scenario you stored data but it is not used frequently, and once in 30 days or more than 30 days it is somebody will fetch that data, then you should use the cool storage so that you will have a pricing advantage than the hot storage over a period of time. Now think of scenario you stored data and again it is not at all used for 180 days, and once in a year or twice in a year you need that data for some reference, you may use it. Then in that scenario you can have archive storage. Okay, so these are the different plans. So based on the hot storage or cool storage or archive storage, what happens is your pricing will come down. but you can't use archive storage and start fetching your blobs frequently. Okay, the reason because it is designed in that way. All right. Now there is something called premium storage or preview that don't look at it as of now. Once it becomes generally available, only start using. So it is always recommended, or my way of thinking is, you understand what it is preview is coming up, but in Microsoft scenario, unless it becomes general available, don't start using it really in your projects. Okay. Now, concurrency. How concurrency is handled in Azure Blob Storage? So there are three modes. One is optimistic concurrency, another is pessimistic concurrency, and last write wins. So in optimistic concurrency, what you do is before updating a resource, you check is it already updated by somebody else, right? Then you fail if somebody already updated. So there is some concept called e-tag is available in Azure resources. E-tag is nothing but when somebody update or create a resource, it creates a string, right? So basically you can compare that before your last read and the update time, so that if there is any change in the e-tag, that means somebody already updated, or it got updated by somebody, right? So based on that, you can implement the optimistic concurrency. Pessimistic concurrency is like you lock your resource so that it is not available for anybody else, and you update that resource. So blob storage provide acquire lease option, so you can use that option and implement a pessimistic concurrency if you are using that mode. Last write wins is the default mode available in blob storage if you don't select optimistic concurrency or pessimistic concurrency. This doesn't check about anything. Whoever is writing the last content, it will be available for everyone. Okay. Now there is something called immutable blobs, or how do you store your business critical data, right? So for organizations like financial institutions, they need the data to be there, right? Nobody should be deleting that secure data. So there is some concept called time-based retention and legal holds. If you apply any of this, what happens is nobody will be able to delete your data. That the data will be secured and it will be available. Okay. Now there are some things to remember when you design your Azure Blob solution. Some are I have just depicted here for your reference. So think scenarios saying that Azure Blob Storage can do MD5 hash automatically. What is the purpose? So purpose is when you have a blob or a file stored in Azure Storage, what happens is if you have a MD5 hash, the next time somebody is going to update the same file, you can actually check the content using MD5 hash comparison. And if it is not changed, you don't need to update that content, right? So this blob storage does that automatically. Now partition naming. So when you create a performance oriented solution, you need to keep in mind saying that Azure Blob Storage use range based partitioning. That means the file names or the prefixes goes to the same partition. So based on that, it goes your blobs are going to the same partition where the file name start, the prefixes matches. Okay. So keep in that mind, because you may wonder that your entire solution is getting a hit or the performance hit based on your code. Okay. Then there is something called recovery point objective, and there is something called recovery time objective. What this both says that when a system goes offline, your storage account goes offline, how soon you can recover your data available, or how soon you can become online for your system, right? So this is an important topic when you go in deeper, or when you create resilient systems. Now other thing is it supports soft delete. Soft delete is just like when you delete, you have that file, that blob will be still available, so that you can recover it back. if by mistake if you did that. Then Azure Search is used to Azure Search you can use to search over blobs you stored across containers. Okay. Then there is something called set and retrieve properties and metadata. So you are writing a blob, agreed, your document or your file is saved, but now how do you basically you wanted to tag it, or you wanted to put an extra details about each blob you are writing, or each document you are writing. So there are system properties or user defined metadata options are available. You can just use this to add your custom metadata, or you can even use system properties. Some are settable, some are read only, but user defined metadata you can put whatever you want based on your solution. Now sometimes if you use Azure storage sometimes if you use Azure storage account from the Azure portal or the subscription directly, it may incur the cost. So Azure SDK comes up with something called Azure Storage Emulator. So while development and testing, you can use Azure Storage Emulator to do your development activities. Okay. Now the following table describes default limits for Azure storage. Not really important, but when you are a developer, but when you are an architect or whoever is designing that system, it is important, because you need to understand what is the scale limits, or what are the limits of the Azure storage account, right? So this table will help you while designing to get how do you scale, or how do you replicate. These all things you should be able to look at this list and do it. I hope this session will help you. I will be releasing one hands-on video soon for Azure Blobs, so that you can apply whatever you understood through this video. Thank you guys. Thank you very much.